Hi everyone, welcome to this webinar titled The Transforming Role of AI in Life Sciences, Enhancing Education and Revolutionizing Research. My name is Dr. Ying Liu, and I am an associate faculty member at the School of Life Sciences, University of Dundee. It's a pleasure to produce this video as we explore how artificial intelligence is reshaping the way we teach, learn, and conduct research in life sciences. Let's begin by exploring the overview and importance of AI in life sciences. This slide sets the stage for understanding how artificial intelligence is transforming the field. The definition of AI, simply put, is the simulation of human intelligence processes by machines, specifically computers. AI is trained using large datasets through a process called machine learning, while algorithms analyze and identify patterns in the data to make predictions or decisions. This involves feeding data into models that are progressively refined to improve accuracy, often leveraging massive computational power to process and learn from complex datasets. In the context of life sciences, AI can enhance our teaching practices, accelerate research, which can lead to personalized medicine, improving outcomes for both research and patient care. For the impact of AI on life science education, I will use personalized learning, virtual lab simulations, and intelligent tutoring systems as specific examples. For the impact on life science research, I will mention how AI can accelerate the identification of disease markers, improve the drug discovery process, and address complex challenges in genetics and infectious diseases. What you're looking at in this photo is the Carnegie Building at the University of Dundee. Many of the faculty who will be teaching you are embedded in the Darcy Thompson unit of the School of Life Sciences, and their offices and a lot of our classrooms are actually in this building. Adaptive technologies play a key role identifying areas where students excel and where they need additional support, making a truly customized education experience. AI-powered tools can tailor content to individual learners' needs, adjusting difficulty and pacing based on performance. AI provides instant feedback on assessments, helping learners identify and address gaps in their knowledge. For example, when a student submits an essay or completes a problem set, AI tools like automated graders or natural language processing algorithm can immediately highlight strengths, pinpoint errors, and suggest specific improvements, empowering learners to make adjustments while the material is still fresh in their mind. AI analyzes learner data to recommend personalized courses, resources, and study plans. And finally, AI-driven gamification and interactive elements keep learners motivated by aligning content with their interests. By leveraging AI, learning platforms can integrate gamified elements such as leaderboards, badges, or interactive storylines. These features adapt to the user's preferences and performance, ensuring that the content not only aligns with their learning objective, but also keep them motivated and entertained, which is crucial for sustained engagement. For example, Serago is a personalized learning platform that uses AI to enhance the retention of complex topics, such as those in biology and anatomy. Serago's AI adjusts the timing of content reviews to ensure students revisit material at optimal intervals for memory retention. The platform analyzes how well students understand specific concepts, such as Krebs cycle, and tailor subsequent lessons accordingly, which creates customized pathways. AI can also track student progress, highlighting areas where more focus is needed, generating performance matrix. Virtual labs offer a risk-free environment where students can experiment with concepts like chemical reactions or microbiology cultures without the danger of spills or contamination. Moreover, they reduce the financial burden on institutions by minimizing the need for physical lab resources and consumables, making them safe and cost-effective. With virtual labs, geography and time constraints are no longer barriers to learning. A student in a remote area can access cutting-edge experiments via a computer or a tablet, practicing scientific techniques at their own pace, whether it's during school hours or late at night. In traditional labs, students may have 1 or 2 chances to perform an experiment due to time or resource constraints. Virtual labs, on the other hand, allow unlimited practice, helping learners refine their skills and build confidence through practice. Virtual simulations can recreate highly intricate experiments, such as managing a simulated pandemic outbreak. These scenarios provide students with hands-on experience in situations that would otherwise be too risky or resource-intensive to replicate. Gamification is a hallmark of many virtual labs, where students can earn badges for completing experiments or navigate 3D simulations. These features make science come alive, fostering deeper engagement and retention of knowledge. Virtual lab platforms often include analytics dashboards that track metrics like experiment completion rates, error frequencies, and time spent on task. Educators can use these insights to identify struggling students and tailor instruction to address specific challenges. Virtual labs can also be aligned directly with course objectives. For example, after learning about DNA replication in the lecture, students can immediately apply that knowledge by simulating PCR experiments in a virtual lab, reinforcing both theoretical understanding and practical skills. A case study for virtual lab simulations is Labster, a Danish company that created many virtual lab simulations in areas such as microbiology, genetics, and molecular biology. During the COVID-19 pandemic, Labster was widely adopted to replace in-person labs. A few highlights of Labster include realistic lab environments. AI can create simulations for experiments like CRISPR gene editing or studying bacterial growth, making it possible for students to interact with realistic virtual equipment. The system detects procedure errors. For example, if someone made a mistake pipetting during PCR setup, the AI can detect it and provide instant corrective feedback and error analysis. AI helps students analyze experimental results, such as DNA gel electrophoresis patterns or spectrophotometer readings. Intelligent tutoring systems, or ITS, adapt dynamically to each learner. Unlike traditional learning environments where feedback might take days, ITS provides instant responses. For example, if a student solves a math problem incorrectly, the system highlights the error, explains the correct approach, and allows immediate practice to reinforce the concept. ITS makes one-on-one tutoring accessible to millions of students. Imagine a classroom where each student has a personal AI tutor, guiding them through challenging concepts, while the teacher focuses on facilitating discussions and addressing broader questions. ITS caters to diverse learning styles. A visual learner might see graphs and videos explaining a concept, while an auditory learner could benefit from narrated explanations. This multimodal approach ensures accessibility and effectiveness for all students. Many ITS incorporate gamified elements like progress bars, badges, and rewards to keep learners engaged. For instance, a language learning system might award points for correct answers, encouraging students to continue practicing while tracking their achievement. At the University of Dundee, the School of Life Sciences is recognized for high levels of student satisfaction, supported by strong student-faculty engagement and hands-on learning. We have innovative programs and state-of-the-art laboratories. There are opportunities for students to engage in real-world research through summer projects and internships. Many of our graduates progress to prestigious PhD programs or careers in academia, biotechnology, or healthcare. Finally, the school holds a Gold Athena Swan Award, recognizing its efforts to advance gender equality and support underrepresented groups in STEM. As we delve into the transformative role of AI in life sciences research, I will use examples of how AI is accelerating drug discovery, unraveling genetic mysteries, and enabling predictive models that improve disease diagnostics and treatment. The photo you're looking at is the research complex in the School of Life Sciences. AI is revolutionizing how we analyze genomic data to identify diseases. Advances in genomic technologies have made high-throughput sequencing a cornerstone of disease research. However, interpreting this data is a monumental task. AI can step in to analyze these vast datasets quickly, identifying disease-associated mutations and biomarkers that will take humans months or even years to uncover. For instance, researchers at Imperial College London developed a machine learning-based system to analyze features from preoperative CT scans, including tumor shape, size, intensity, and texture to predict patient outcomes. Scientists have also used AI to identify rare genetic disorders by comparing patient genomes to large genetic databases. Understanding diseases often requires more than just genomic data. AI can integrate genomic information with proteomic, transcriptomic, and epigenetic data, offering a holistic view of how diseases develop and progress. This approach is particularly valuable in studying complex conditions like neurodegenerative diseases. By leveraging machine learning algorithms, researchers can sift through vast amounts of genetic information to pinpoint mutations linked to conditions like cancer or rare genetic disorders. AI-driven genomic analysis paved the way for personalized medicine by tailoring treatments to the genetic profiles of individual patients. For example, AI can predict how a patient's unique genetic makeup will influence their response to a drug, allowing for customized therapies that improve outcomes and minimize side effects. Traditional drug discovery methods involve screening thousands of compounds, a process that can take years. Machine learning transforms this by analyzing vast datasets to predict which compounds are most likely to succeed as drug candidates. This dramatically reduces the time and cost of drug discovery. Understanding how a potential drug interacts with its target is critical to success. Machine learning models simulate these interactions, providing insights into binding affinities and mechanisms of action, which can accelerate the design of more effective and targeted therapy. Machine learning can also help mitigate risk of drug discovery by predicting toxicity and efficacy in preclinical stages, ensuring that only the most promising candidates advance to the next stage. Clinical trials are expensive and time-consuming. Machine learning improves trial design by identifying the most suitable patient populations, predicting potential outcomes, and suggesting optimal dosage. This leads to more efficient trials and faster regulatory approval. During the COVID-19 pandemic, machine learning demonstrated its power by identifying existing drugs like remdesivir as potential treatments. By analyzing large databases of drug interactions, machine learning continues to uncover new therapeutic uses for approved drugs, offering faster solutions to emerging health crises. The University of Dundee's Drug Discovery Unit is a leading center for translating basic scientific research into potential therapeutic candidates across various disease areas, such as malaria and neglected tropical diseases like leishmaniasis. AI can help scientists and clinicians analyze patient family medical records to identify inherited patterns that might predispose individuals to genetic disorders. For instance, an AI system can analyze generations of medical records to detect risks for hereditary conditions like BRCA-related breast cancers or Huntington diseases. By integrating genomic data with lifestyle and environmental factors, AI or machine learning models create highly accurate risk profiles for genetic disorders. For example, AI can combine a patient's genetic markers with their dietary habits to predict the risk of developing type 2 diabetes or cardiovascular conditions. AI identifies subtle genetic markers and correlations that might be overlooked by traditional methods. This enables early detection of conditions like cystic fibrosis, allowing for earlier and more effective intervention. AI can streamline population-level genetic screening by identifying individuals most at risk for certain conditions. For example, AI-driven platforms in public health initiatives can analyze genetic data to prioritize individuals for following up screenings or preventive measures. In terms of infectious disease surveillance, AI can revolutionize disease surveillance by pulling data from multiple sources like hospital records, social media posts, and weather reports to monitor outbreaks in real time. During the COVID-19 pandemic, AI tools tracked infection rates and symptoms across populations, providing timely insights for policymakers. Machine learning models predict where and when outbreaks might occur by analyzing historical data, population density, and environmental factors. For instance, AI has been used to forecast dengue fever outbreaks based on weather patterns, enabling targeted preventive measures in vulnerable regions. When a new infectious disease emerges, understanding the pathogen's genome is critical. AI accelerates genomic analysis by identifying mutations and linking them to transmission or drug resistance. This was pivotal during COVID-19 pandemic, where AI tracked the evolution of variants like Delta and Omicron. AI-powered systems detect unusual patterns in health data, such as spikes in fever or respiratory symptoms, providing early warnings of potential outbreak. These systems give public health officials valuable time to prepare and respond before diseases spread widely. AI identifies disease hotspots and predicts resource needs, ensuring supplies like vaccines and medical personnel, and who can forget PPT crisis during the pandemic, are sent to the areas that need them the most. Another example is during an Ebola outbreak, AI actually guided the allocation of treatment centers to maximize impact. The University of Dundee's School of Life Sciences, or SLS, is renowned for its groundbreaking research and contributions to the scientific community. Here are some of the school's recent highlights. In the UK's Research Excellence Framework 2021, the University of Dundee was ranked as the top university for biological sciences, reflecting the high quality and impact of research conducted within the SLS. The SLS has established significant partnership to advance drug discovery. It also provides a dynamic research environment with cutting-edge facilities, which support a wide range of scientific investigations and innovations. The SLS received the Gold Engagement Watermark from the National Coordinating Center for Public Engagement, recognizing its outstanding efforts in making science accessible to the wider community through various outreach programs and partnership. In recent years, a £26 million Discovery Center for Translational and Interdisciplinary Research was inaugurated to enhance the university's capacity in life sciences, particularly in drug discovery. This facility supports interdisciplinary research and fosters innovation. Thank you for your attention. We hope that this gives you some insight into how AI is transforming life sciences, education, and research, and give you some idea about the life sciences education and research capacity at the University of Dundee.